Hey guys, welcome to the first video covering synthesis. Okay, so from now on, usually every test we'll have one of the questions will be a synthesis question. Okay, and so these are going to be the videos set on um, just the synthesis reactions and I guess strategies that you can use to approach these kinds of questions. And also I'll work through a bunch of examples for you guys so you can see how we can apply just the synthesis stuff. Okay. And so I have two pictures here. On the left is called a synthesis toolbox, and on the right is an example synthesis question. So the synthesis toolbox is just a bunch of reactions that they may give you um, just as like some basic reactions to use for synthesis questions. That doesn't mean that any of these reactions must be used in your synthesis, but they can help you. Um, when I took this class last year, the first time we did a synthesis question on a test, the toolbox was given. After that, it was not. So you may have to write it on your card. But yeah, okay. Um, and so you can see that there's a bunch of reactions here. One of them, if you're watching this on the workshop for your first, the workshop focused on synthesis, one of these reactions is left out, which I'm pretty sure is the H2PDC reaction, but that's just an alkene reaction. You guys have seen that before. And also, you should know that you're not required to stick to these reactions when doing synthesis. You can use any of your reactions that you learned, like in terms of alkene reactions, like Br2 to add two bromines or something like that, or acid catalyzed hydration where you have like H3O plus over H2O. All that stuff is perfectly fair to use for the test. And the more you learn reactions in Orgo 1 and 2, the more your knowledge of uh, what reactions you can use for synthesis questions will increase. Okay. And so this video is just going to focus on the basic reactions and using this problem we have on the right to help us work through it. So it says using the library of synthetic reactions proposes synthesis of the following compound um, from compounds containing 4 carbon atoms or less. Okay, so usually in synthesis questions, they're going to ask you to start from a certain number of carbons, right? And so that means that your starting reagents have to have at least either 4 carbons or they could be less. Okay. Now they gave you the final product, so you now have to figure out what you start with. Okay. So for these questions, it's actually usually easier to work backwards. Okay. It's going to be a little bit harder to go at this going forward. So we're going to try to work backwards with all this. So if you're going to use in the future any of your reactions like alkene reactions, or the future reactions you learn in Orgo, it's best to be able to know them so that you can actually use them backwards as well. Okay, and know that there are multiple acceptable answers for synthesis. Usually in the answer key, they'll only show you one, but as long as your synthesis works, even if you found it differently, you'll get the full credit. Okay, but it has to obviously check out. And so you need to make your synthesis work essentially 100% of the time. All right, you can't have like a mixture of products because that can make you lose points. All right, and so let's start out with our example. So I'm going to just redraw it. Okay, so we have this alkene. And let's look at our synthesis toolbox, right? You can see that since we're working backwards, we want to really look at the right side. So what on our right side of our toolbox, on the right side of the arrow, has an alkene? Well, this reaction right here has an alkene at the end. And also I've kind of shaded out one of the reactions. You'll learn it a little bit later, but I don't want to confuse you guys right now by putting it here until you learn it. And so I'm not going to, whatever's in red, I'm just not going to show you guys. Okay. And so we have that reaction as a Br with some sort of base, OR minus, where the R is some sort of alkyl group, like some carbon chain, or OH minus, gives us a double bond. And that's called an elimination reaction. Okay. And so what we're going to do is we're going to put OH minus. And now we know that we're going backwards. We start with a double bond, and now we're going to put a Br. And you can see that it's on one of the carbons of that double bond. So the question is kind of what carbon are we going to put it on? So I can have a Br right there, or I could have put it right over here. Okay, But the question is, how do we know which one it is? So the way I like to do these questions is once I go back one step, I evaluate it going forward again to see if I'm getting everything 100% of the time. Okay. So the way that this elimination reaction works with OH minus, you guys will learn more in-depth elimination reactions in the future, and that can change based on the base you use, how it works. But the key thing to remember when you're doing OH minus or OR minus is that you want to form the most stable double bond. All right. So when you have your BR and going forward, so now I'm looking at it, I'm evaluating the reaction going this way. You need to form the most stable double bond. Okay. And so you can see that if I'm looking at the top structure right here, this one, I can form two possible double bonds. I can form the double bond this way, or I can form the double bond this way. Okay. So if we compare them, this one right here, that double bond has two carbon substituents on it, right? It's a di substituted. And if we compare this one now, our double bond has three carbon substituents coming off of it. So if we put that Br on this carbon over here in purple, we're going to get the most substituted one 100% of the time. So that's going to be that one. You're not going to get this lower one, okay? And so we know that that BR, where we put it there, is okay, so that's fine. Let's look at this one over here now. We can have, again, two possible double bonds. We can either form it this way, or we can form it like this. And it doesn't matter which of those methods you pick, there would be the same, okay? And so evaluating this is going to have three carbon substituents coming off the double bond. This only has, this has two, right? One there, one there. And so the above one will be the more, will be our product 100% of the time. And so it's not going to be the lower one. And so essentially we could have put a BR into any of those spots, right? So this is a case where a synthesis reaction can have more than one ways of doing it. I could either form it on the left or I could form it on the right, all right? I'm going to do this one picking the BR on the right, okay? The one that's where it's kind of to the right in the middle, all right? And so that's what I'm going to do. You could have picked it the other one. And so we have our BR now. And now let's look at our synthesis toolbox. What can we do with a BR, right? Remember, we're working backwards. So we need something where our product on the right-hand side of the arrow has a BR, and we see it would be this reaction right over here, okay? And so what it does is going backwards with, once you have a BR compound, you can write HBr, and we replace our BR with the OH, like that, okay? And so, yeah, we have an OH. You will learn in the future when you learn substitution and elimination stuff, other ways of doing this one reaction right here, where you have an alcohol and you do HBr to Br, okay? But for the purposes of this test, it's just you just use HBr for that, for the initial synthesis stuff that you guys are doing. And so you can see I had a Br, and going backwards, I just put an OH exactly where that Br is, all right? So that's all you need to do. Yep, you can see that right here. This alcohol has right here two carbons coming off it, or three actually total, and this Br three carbons. We put it on the same exact spot. Okay. Oh, and I left out a methyl. There we go. Okay, so now we have that structure. Now we have an alcohol, and so let's look at what in our synthesis toolbox has an alcohol on the right-hand side. You can see it's this reaction here. Okay. And so what this reaction does is it essentially cuts the molecule, okay? And so let's kind of like take this step by step. We have an alcohol off of a carbon, so I'm going to color that carbon green right there, okay? Let's zoom in. So we have that carbon that's green. We have two R groups. The R groups can be hydrogens or carbons. Doesn't matter. So I'll just color those in purple. Okay. And we have the rest of our chain. So I'm just going to color that in blue. And let's do the same with what we have here. So the carbon with our that has our OH is going to be green. So let's color that green. And let me pick a lighter shade so we can see it better. That's green. Okay. Let's look for two R groups coming off of that carbon. Okay. So remember, our R group can be a hydrogen. So just to be safe, we draw a hydrogen. Okay. And we have a carbon chain. Okay. So in this case, we have two carbon chains and one hydrogen. So one of them will be our R group. The other one will be a hydrogen as one of the R groups. Okay, so that's one of our R groups. This is another, and this is our blue chain. Now it doesn't matter which carbon chain you picked; it doesn't really matter. And so all we do, and I'm going to just erase this just so we can see it better, is you pick one of the carbons, or you pick one of the bonds coming off of this carbon that the OH is, one of the green carbon. So either here, or let's choose a different color so we can see both options, or here. All right. And so this reaction going backwards essentially is a cut. Okay, we're going to cut it. Going forward, it's going to combine things, but going backwards, we cut, right? And so you pick one of those carbons, and we're going to cut it going backwards. And so what you do is I'm going to do two versions. One where we did the blue one, and one where we do the purple one. So you guys can see both. All right, so we have two here. So let's do the purple one first, okay? So when you cut it on the purple end, what you need to do is you need to look at what we have on the synthesis thing right here. You can see that this blue chain that I colored is going to end up with a lithium on it, okay? Where that green carbon used to be almost, okay? And you can see that the OH ends up on this reagent right here as a carbonyl. And so I'm going to show you guys what the product is going to look like, and then we can see how it happened, okay? And so let's see this. We're going to have this structure here. And you see how it's numbered over here, step 1 and 2, in terms of the cutting step, right? You must number that. If you do not, you will get this question wrong. It will take off some points, okay? And so now I'm going to end up with this. Okay, and so, and step 2 is just H2O. For step 2, you could either have H2O or some sort of acid. So like I could just write H plus or H3O plus, it doesn't matter. All right, so let's look at how we did this, okay? So I'm going to draw our two little reactants here, okay? And so the way this works is we have a lithium, right? Lithium isn't really attached the way it looks like in this structure. It's really having a positive charge, and that carbon over here has a negative charge, okay? So it exists as a salt, but we just write it with the lithium kind of bound to it. And so all you do is you essentially kind of think of it as overlapping right here. So we take this lithium, and I'm going to put it, let's just erase the hydrogen. So I'm going to just overlap our lithium directly onto the carbon of the carbonyl. Right there. Okay, let me just connect this a little bit better. As you see, it's going to put it right there, and I'm going to change the carbonyl to an oxygen. and we have exactly what we started with. Okay, so it cuts it. So I'm going to cut the bond. So we separate them, and we have two parts now. The OH is going to turn into a carbonyl. Okay, and remember there was an H over here, so that just becomes right there. Plus this. Now you can see that, remember, always count your carbons. If I count it 1, 2, 3, 4, 5, 6, 7, 8, I have 1, 2, 3, 4. You can see that carbon 5 is split from carbon 4. So carbon 5, 6, 7, 8. Okay? And the carbon that was split is going, the carbon part of that bond that was split is going to have the lithium. The one that had the OH is going to become the carbonyl, and the other one has the lithium. And so just to get it more practice, let's see the blue step. Okay, and so let's see, we split it on the blue end. So let's redraw this actually so we can see it better. This OH. Now we're going to cut that, cutting the bond, number 1, 2, 3, 4, 5, 6, 7, 8. So the bond between 2 and 4 breaks. To draw that first. Okay. I'm not even going to draw in the lithium or anything yet. Okay. Number again, 1, 2, 3. Oh, I drew that incorrectly. Oh, no, I didn't. So we're going to have 4, 5, 6, 7, 8. Now remember, because we split 2 and 4, the atom of that bond that had the OH becomes a carbonyl. So carbon 4 had the OH, so that becomes a carbonyl. And remember, we had a hydrogen over there, right here. And the carbon that didn't have that OH gets a lithium. Okay? Always count the carbons. You're not supposed to be adding any carbons like this. So like, you're not going to have this instead, right? Because we didn't have that many carbons on that left-hand side. And so we could have cut this molecule in two different ways. Okay? Now, you need to be careful with the way you're picking it. Okay? It says that you need to start from 4 carbons or less. That includes the reagents that you use to cut. Okay? And so let's write actually what we had above the arrow here. Okay? We're going to want to put a carbonyl molecule on the arrow. So step 1, we'd have H here. And step 2, we can do H plus or H2O or just any acid. The point is the protons. Okay? And so let's look at how many carbons we have in both of our scenarios. And so I'm going to just erase this stuff so we can see a little bit better. We drew out 2 scenarios how we can cut this molecule. Oh, and let's finish this out here. Okay, those 2 arrows. So let's count. We have 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, so we have 4 here, so that's good, and we have 5 over here. Now the thing is, you are allowed to use that 5 carbon one. Okay, the only thing is you can't just do it like this. If we pick the one with the purple end, we can just keep going right from what we have over here, this one. The thing about the one labeled as the one on the left with the blue is you're going to have to also synthesize the that step 1 part. So essentially, I would write it as this. We have our arrow coming out, and I would just do. Let's change that up. This with this. Okay. And then step 2 would be H plus, and I would write the 1 here. But then I would also have to branch out and synthesize that, as well as keep going with this. Well, actually, no, you're done with that one. It's the correct number of carbons. It's 4 or less. Okay, and so I would have to synthesize that as well. Okay, but you didn't learn one of the reactions for that, and so I'm not going to show you that. So I'm just going to continue off of this one, the purple one. Okay, and so we have our step 1 reagent was 4 carbons, and our reagent here was 1, 2, 3, 4, and they only asked us for 4 carbons or less. All right, so that's great. We have our 4 carbons. The only thing is you don't want to really leave a lithium there. So we're going to finish this out. If you see that here we have a lithium on the right-hand side of the arrow, it's going to be that reaction. All you need to do is go backwards, write a lithium, and it'll replace it with the Br. And you're done. Okay, and so let's go forward with our synthesis, and which is what I always like to do when I took these tests into the synthesis questions, is I would, once I've got it backwards, I do it over going forward to see if it all makes sense. So we start with this 4 carbon chain. You go forward adding lithium. We just replace the Br with a lithium. Let's check. Yeah, it has a Br. You just put a lithium and it replaces it with lithium. Step 1 is good. Next, we're going to have this 4 carbon chain with the lithium, and we're adding it to this carbonyl group. Okay, so remember, going backwards we cut. So going forwards we're putting them together. And so I'm going to show you how it like overlaps almost. Actually, let's delete the hydrogen. Makes it easier. Okay, and we have our lithium. So I take this, just going to put it right over, and it turns the the carbonyl to OH. All right, we have that exact original molecule, so that works. Okay, and now going forward, we had an OH, and so we added HBr. So adding HBr just replaces an OH with Br. That works. And then we had an elimination reaction. We put an OH minus and it removed the Br and put a double bond in its place. Okay, and so remember, we're always going to form the most stable double bond we can. And so that's going to either be on the left or right hand side. On the right hand side, it would form it like this, which is not as substituted as this one. So we know that the one on the left is going to be the one that forms the 100% of the time, which is exactly what our original answer, our original compound was that they gave us, right? This. And so this is a synthesis that would give you credit on the test. In the next video, I'm going to just explain the cutting a little bit more. In the next video, I'm going to explain the cutting a little bit more in case you were a little bit confused by it, because it's probably going to be the most confusing thing about synthesis that people end up kind of messing up because they don't either count the carbons or they're just having a little hard time visualizing it. Okay, and then we can do some more examples and even incorporate some of our alkene reactions, because there will be questions they'll ask you where you have to use reactions outside the synthesis toolbox. You can't just rely solely on that. Okay, so I will see you guys in the next video. If something here didn't make sense, please feel free to go to the CLC or email me. And also, these videos are on YouTube, and so if you're watching them there, you can always comment your questions, and I'd be happy to reply on there too, so that others who watch the video can also see, because chances are if you have a question, others have the same one. All right, and I'll see you guys in the next video.